Hello everyone, let us see next example. Example number 23. If the question is, if u minus v is equal to bracket x minus y bracket complete into other bracket x square plus 4xy plus y square, u minus v is given, and f of z, as per usual notation, u plus iv is an analytical function of z. We have to find out f of z. In this particular example, we have to find out f of z, but instead of u and v, they have given combination of arithmetic subtraction of u and v, that is u minus v, and from that we have to calculate or find out f of z. Okay, let us see. Let our first sentence is f of z is equal to u plus iv be the analytical function. Obviously is the analytical function. It is given in the example. Okay, now we have to make some adjustment here. Multiply both the side by I. Okay, so that we want u minus v here. U is present here, v is present here. If you multiply both side by I, this is a one adjustment, arithmetic adjustment. We get I into f of z is equal to I into u plus I square, I into I square into v. We know I square value is minus 1, that's why I of f of z is equal to iu minus v, because I square value is minus 1. Now subtract these two or add these two. Addition, add above two equations. We can add arithmetically two equations like that only. Add LHS side and RHS side. We get f of z plus I. F of z is equal to u minus v. Put the bracket plus this is I, this is also I, take common, v plus u, that is u plus v. Okay, that is now from LHS side f of z is a common bracket, take out f of z common, we get in the bracket 1 plus I is equal to u minus v plus I into u plus v. Okay, now we have this u minus v here. That's why let this convert this equation into such equation such that this total term becomes f of capital F of z is equal to, this is capital U and plus I into this is capital V. Okay, this is our assumption. Now we have given u minus v. Okay, u minus v, that is this term we have given already. This is the term. Okay, and we have to find out f of z, and by earlier method we can find out f of z by using Milne-Thomson method. Okay, here what is the difference is, we have to just put, instead of u we have to put, now this is our original equation f of z analytical function. Okay, that's why capital U, capital V and capital F of small z should be we can use here in new format. Okay, that's why by Milne-Thomson method, now apply Milne-Thomson method to find out f of z, capital F of z obviously. Okay, from this equation where capital U is u minus v, which is given. Okay, this is homework for you. Milne-Thomson method we have already studied in earlier example, and depend on that we have one more homework also. Okay, this one. That's why this is homework for you to find out capital F of z in terms of z, and answer for this is I am directly giving you. It is f of capital F of z is equal to, and bracket 1 minus I bracket complete into z cube plus integration constant c. Okay, solve this by using Milne-Thomson method. This is your homework for you. After solving that, the answer you will get the answer this in the form of z. Okay, now we get capital F of z, but what is our aim, what is our original question? We have to find out small f of z. That's why we have to put again capital F of z is equal to this, and Now from here, call this as equation 1. Okay, therefore from 1 put f capital F of z is equal to 1 plus I small f of z here. Okay, from this we get this equation as this LHS side becomes 1 plus I into small f of z is equal to this term as it is. Okay, now we want f of z, that's why take all the constant on that side. We get f of z is equal to 1 minus I upon 1 plus I into z cube plus c upon 1 plus I. 1 is constant, I is also constant, and c is also constant. That's why put all together this term as a c dash, that is another constant. Okay, z cube as it is. And to solve this is our answer. Now to simplify this, just multiply and divide the numerator and denominator, multiply by opposite conjugate of this factor. What is complex conjugate of this factor? 1 minus I. Multiply and divide. What we get? 1 minus I. Multiply to the numerator, we get 1 minus I bracket square, and 1 plus I into 1 minus I. Denominator we have a plus b into a minus b, that is a square minus b square, that is 1 square minus I square. In the numerator, expand the bracket using a minus b bracket square, that is a square minus 2 ab plus b square. Now we know I square is minus 1, that's why minus minus becomes plus 1. Plus 1 is 2, and this is again I square minus 1, plus 1 gets cancelled, numerator becomes minus 2I only. Z cube c dash as it is. 2 get cancelled. Final answer for f of z is minus I z cube plus c dash. This is just a simplification to avoid this factor. Okay, now this is one more example homework for you. Find analytical function f of z if u minus v is this. Answer is this. Okay, same question. This all, that is our homework. Okay, now let us see next. Point, that is transformation or mapping. This is very easy point. Let us see the definitions, some more theoretical part. That y is equal to f of x is a graphical representation in xy plane. Obviously y is equal to f of x is a function, any function, and where two variables are there, x and y. That's why it is if you plot this graph, or if you plot this curve on this graph, we get the graph on xy plane, because only two variables are there. Okay, if z is equal to f of xy is a surface in the three-dimensional space. Okay, like this. Okay, this is suppose x-axis, this is y-axis. Okay, if we draw any suppose this is any line. Okay, this is the line in xy plane. Okay, and suppose this equation of this line, suppose x plus y is equal to suppose 1. Only two variables are there, that's why this is the straight line in a x and y plane. We need only two variables. While z is equal to f of xy is a surface. Surface means this is a plane. If we bend this, it becomes surface. Okay, and to imagine this surface, you need one more extra dimension. Okay, for this suppose this is, for this plane you need only x axis and y axis, but if you bend this, you need one more axis, this is z axis. X, okay, x, this is y, and this is again height is there, that is z. That means we need three-dimensional space x, y, z. Therefore z is a surface in a three-dimensional space. But this method is not hold for complex variables. Suppose we add some complex numbers or complex variables or complex function in such equations, then it doesn't in some cases this method is not valid, or it doesn't hold for complex numbers, complex variables, this method. That's why we have to define some more transformations or mappings, okay, or functions. Okay, now we consider here two planes. We have two planes. First one, z plane, which consists of x and y axis, okay, two variables, and other variable, parallel plane, which is w plane, which consists of two variables again, u and v. Okay, like our analytical function f of z is equal to u plus iv, in that sense. Okay, therefore w is equal to f of z represent the correspondence between points x and y and u and v. This equation represent the relationship between z plane and w plane. Okay, that is, to each point xy from z plane corresponds to a point uv in w plane. Therefore w is equal to f of z defines the transformation or mapping of the z plane into w plane. Okay, this is the uh, definition of mapping or transformation. Depend on that we are going to solve so many examples. Okay, let us see now next definition, conformal mapping or conformal transformation. Mapping and transformation words are same. Let us consider two curves c1 and c2 in z plane intersecting at point P, and let the corresponding curves c1 dash and c2 dash in w plane intersecting at point P dash. Suppose this is z plane, this is w plane. Okay, x and y are there. W plane consists of u and v. Suppose these are two curves c1 and c2. Okay, this is c1, this is c2 here. Okay, this is c1, this is c2 curve in z plane, and this is again c1 dash and c2 dash in w plane. Okay, if we draw, if this is the point of intersection of these two curve P, and this is the point of intersection of these two curve in w plane as P dash. Okay, if you find out the angle, suppose draw this tangent at this point to this curve and draw this tangent, okay, at this point to this curve. Okay, and if you find out the theta angle between these two tangents, and suppose same here, if you draw tangent at this P dash intersecting point to this curve and tangent at this curve at this point, if you find out the angle between these two in tangents, that is theta dash, suppose theta dash is there, then in this case theta must be equal to theta dash. Okay, if theta is equal to theta dash, angle, these two angles are same, then such mapping is called conformal transformation or conformal mapping. Okay, now let's see next. Here some notes are there. Number one, write down in your you can write down in your notes. If w is equal to